Okay, we're going to start with our warm-up. Who wants to share, raise your hand, what you put down? Tilla? Ooh, love it. That is our one where the triangle balance is, right? Caitlin?
I learned that the length of the triangle, like the length of one side of the triangle, can help determine the side angle of the approximate and vice versa.
Perfect. Love it. Very, very important concept from chapter 5. Nailed it. Okay, Amron, last one. Oh, and you just learned that today, didn't you? Okay, nice. So, if you're looking at your outline at all, we are moving on from triangles to quadrilaterals. What we focus on in chapter 6. Today we don't get too into quadrilaterals. We kind of look at different types of polygons, and we're specifically focusing on the measure of the angles of polygons, both interior and exterior. That's what we're going to focus on today. And then you can see as we work through chapter 6, we'll get into all types of quadrilaterals. And there's so many good ones. Parallelograms, trapezoids, squares, kites. There's just so many fun ones. Okay. First thing to help us kind of lead into the first big idea here is this vocab word of something called a diagonal. So if I have any type of polygon, specifically in this picture, how many sides does this polygon have? Sorry, don't look at the red lines.
5.
Okay. 5. It is a pentagon. Good. 5 sides of a pentagon. So a diagonal is any segment that connects two non-consecutive vertices. When I'm talking about vertices, I've been using this vocab word like a lot with triangles. We're talking about points that form a triangle. Okay? So when I talk about vertices in any type of polygon in this pentagon, all those points right there, which in geometry we label with capital letters, those would all be vertices. So if I take, let's say, point P, and I connect it to any non-consecutive vertice, what do we think that means? Yeah, two vertices that are not basically on the same line or not right next to each other. Good. So I could connect it to S. That would be a diagonal. I could go from P to R. That would be a diagonal. Any segment that connects two non-consecutive vertices. All right, so what this helps us do is find kind of like our first little formula here of looking at the sum of the angle measures of the interior angles. Okay? So let's start with what we know. Interior angles in a triangle, so like these three angles, will always have a sum of how many degrees? 180, right? We talked about that a lot. Triangle, they're always going to sum 180. So if you kind of read this blurb up here, it says, if we draw all possible diagonals from one of the vertices is just plural of vertex, guys. So let's say now I have a quadrilateral, which is how many sides? 4 sides. And I draw in all the possible diagonals from just one of the verteces. Let's just say it's that one. I see that every quadrilateral is really just two triangles put together. So how many total degrees do we think are in this quadrilateral? 360. Why? Exactly. I have two triangles. 180. 180. I have two triangles. So it's going to be 360. Okay, let's continue this thinking. Pentagon is 5 sides. How many triangles does it look like I'm forming there? 3. What's 3 times 180?
540.
Good. 540. So guys, what we're finding here, this is what the interior angles, I'll highlight them quick. That's what those angle measures will have a sum of. They'd add up to 540 degrees. All right, how many triangles can I draw in this hexagon? 4. So 4 times 180 gives me 720. Yep. All right. Let's talk about any patterns we notice here. We're timing by 180 each time.
Right, as a triangle.
Okay, as my number side goes up by 1, it's just another triangle. Good, that's a good pattern. How do I know? How do I know how many times I times 180 by?
How many- How many diagonals?
But what if I just said like, okay, what if it had 17 sides? Nope. How many sides are in a quadrilateral? Did I do 4 times 180?
You divide by 2.
Okay, that's a good guess. Let's start. How many sides does the pentagon have? 5. Did I take 5 times 180?
Minus 2. Yeah, by pointing to the sides.
Whoa! Everybody see that pattern?
Yeah, 'cause it's
I take my number of sides. How many sides does the quadrilateral have?
4.
What's 4 minus 2? Okay, let's see if that works for this one. How many sides does the pentagon have?
5.
5 minus 2?
3.
Hexagon has how many sides? 6 minus 2? Could that be how many times I'm going to times 180 by? Yes, it is. That's basically where this formula comes from right here. I would highlight this if you have a highlighter or box it or something like that. The sum. And remember, this is for interior angle measures, because we'll look at exterior in a second. Interior angle measures of any n sided, such as saying any number of sides. The sum of their angle measures, the sum of the degree measures, is going to be your number of sides minus 2 times 180. That's basically the formula. My number of sides minus 2 times 180. So in this little theorem box here, how many sides does this polygon over here have? 5. So to find what those interior angles are going to have a sum of, I would take my 5 minus 2, my number of sides minus 2 times 180. You already did that one. That was the 541, right? For pentagon.
Yeah.
Those are going to have a sum of 540 degrees. So let's go back to that 17-sided polygon that I said. How many times would I actually have to times by 180? 15. Good. 17 minus 2. 15 times 180. Okay. That's really the theorem. I'm just going to caution you because this is going to feel easy. But just be very careful when you're like reading the problems because they're kind of easy to like mix up where I see people just try to like rush through it and don't fully read what they're actually asking to find. So let's start with this first one. It says find the sum of the measures of the interior angles of a convex nonagon. Woofda, this is a lot of vocab. Let's start back here actually. Nonagon is how many sides? 9. It is 9 sides. This vocab doesn't change how I'm going to approach this problem, but just for practice, because we talked about this in chapter 1, does anybody remember what convex means?
Yeah.
no, it's like not a normal shape.
No, it's
That's
kind
Okay.
It's kind of cave.
So it's open. It's like an even. No cave.
Yeah. Okay. I kind of think what I get what you're saying, Matt. But basically, so this would be like concave when it like indents, right? And our kind of test for it is if you like extend the sides, and if the sides pass through the inside, then it's concave. So convex is like it kind of just like sticks out. It doesn't necessarily have to be like all the same lengths, but if I were to extend all the sides, it would never pass through. Okay, that doesn't matter about how I'm going to solve the problem, but just a good kind of vocab reminder, convex. All right, now they're just straight up asking me to find the sum of all the interior angles. Okay, so to do that, oh my gosh, must not have locked anything in place here. I got to take my number of sides, which is, oops. That's not what I meant to do. I got to take my number of sides, which is 9 minus 2 times 180. Now just make sure you do order of operations first. You'd have to do 9 minus 2, which is 7, then times 180. So those interior angles are going to have a sum of 1,260 degrees. 1260. That's all you have to do. Okay. Notice how this problem's a little bit differently. It says in a regular heptagon, what is the measure of each interior angle? Now, let's start with some vocab. Heptagon, how many sides? 7. Anybody remember what regular means? What are all the same? sides and angles. Good. A regular polygon, we talked about this in chapter 1. Regular polygon is all sides. I can write this down if you don't remember it. And angles are congruent. So for example, relating this back to our triangles we just talked about, a regular triangle is just an equilateral triangle. All the sides are the same, all the angles are the same. Okay. So I can start by finding the sum of the interior angles for a heptagon. Let's start there. The sum of all the interior measures would be my number of sides minus 2 times 180, and that's 900. But that's not what they're asking me to find. How would I find the measure of each interior angle? Cameron? Divide by 7. If there's 7 sides, are there going to be 7 angles?
Yeah.
Yes. Think of a triangle. 3 sides, 3 angles. Heptagon, 7 sides, 7 angles. I'm going to take my totals, 900, divided by how many sides I have, which is 7. So each of those, because it is regular, we can do this. Each of them are going to be 128.6 degrees. Not too bad. Let's try another one. You just got to read carefully. A mall is designed so that 5 walkways meet at a food court that is in the shape of a regular. So again, regular. All sides and angles are congruent or are the same. Are we all right? Of a regular pentagon. How many sides is a pentagon? 5 sides. Find the measure of one interior angle. I just want one of them. Maybe that one. Maybe this one up here. Well, let's start with the sum, just like we did in the last one. My sum would be my number of sides, which is 5 minus 2 times 180. 540. So each, since this is regular, would be 540 divided by how many angles do I have? 5. It's the same as the number of sides, so they're each going to be 108 degrees. Okay. The next problem is a little more difficult. It's kind of fun. Again, let's read it carefully. Look at the information given in this problem. It says the measure of an interior angle, so just one of them, of a regular polygon, I don't know what type of polygon, is 150. Find how many sides this polygon would have. All I know is that it's regular, meaning what? Yep, all sides and angles are the same. Okay. So I'd be curious to kind of let you guys like try out this problem, and maybe we can another time, but an easy way to get there is basically just to kind of use your formula backwards. All right. So here's what I know. Don't write this down. That whatever type of polygon is, each one of these, because it's regular, so they're all the same, each one is 150. There's a lot that goes into it. We don't know how much they need in total, right? Because we don't know how many sides there are. So if I use my formula, my number of sides minus 2 times 180, that has to equal my sum. Here's what's tricky. I don't know my sum, but I know each of them is 150. And I'm going to have the same number of angles as number of sides, right? So for my sum, I can just take each angle, which is 150 degrees, and I can times it by my number of angles, which is the same as the number of sides. I'll say that again. Because each angle is 150, we don't know how many angles we have. Oopsie. We don't know how many angles we have, but we know it's the same as my number of sides. Okay, so this is kind of my formula backwards. So the sum is going to be 150 times however many angles I have. All right, and then just treat this like an algebra equation and solve it for n. N is my number of sides. So here I distribute the 180. People's mistake is they'll often set this just equal to 150, but that's not my sum. That's only one of the angles, so you just got to be careful. Okay, I'm going to move all my variables to one side. Now, I know this is going to give me some negatives, but that's okay. Because I see I'll end up dividing a negative by a negative. And I end up getting positive 12, which makes sense because it's my number of sides. Now, I could check this answer. Let's do it quick. Let's take 12 minus 2, which is 10, times 180, which is 1,800. Is 1,800 divided by 12? Let's do it quick. 1,800 divided by 12, would that give me 150? Yes, it does. Okay. All right. Let's try some with algebra here. You did problems like this a lot when we had triangles. You would just take those three angles, whatever variables were attached to them, add them all up, and you total them to 180 because you knew in a triangle that angles always had to add up to 180. But this one's different. Is it triangle? No, it's quadrilateral, specifically it's parallelogram. So when I add all these interior angles together, how many degrees am I going to total it to?
360.
360. Good. If you don't know that, use your little formula. Take your number of sides, which is 4, minus 2 times 180, and you'll get that number. And that's going to be what you're going to set them equal to. So I'm going to add these all up, and I notice I have a couple repeats, so I'm just going to double them instead of writing them each out twice. It's the same math. But here's the big difference. I'm going to set them equal to 360. Because it is a quadrilateral, and that's what the interior angles are going to total. All right, so whether you choose to double them or just straight up add all four angles, doesn't matter. We should all still get the same answer. I'm going to do this quickly because we don't know how to solve equations. X is 11. Now, they didn't just ask me to solve for X. They asked me to find the measure of each interior angle. So I just got to go back and plug them in. So R is 5 times 11, 55 degrees. And I see that R is the same as T. They're both labeled 5X. So they're both going to be 55 degrees. Okay, angle S, 11 times 11, 121 plus 4 is 125 degrees, and that's going to be the same as angle U. We'll kind of talk more about parallelograms and all their characteristics and how those opposite angles are congruent and all that stuff later on. In another lesson. Okay, so I know I kind of solved that fast, but all it is just solving the equation and plugging the number back in, which I know you guys can all do. We're going to try one more like that. And this one's different also. It says find the measure, same directions though. Each interior angle of this polygon. What type of polygon is this? It is irregular. How many sides does it have? 5. So it's a pentagon. So when I do my equation, when I add all of these up, what am I going to total it to? 180?
540.
540. How'd you get that?
Our boy's 5 sides minus 2 times 180.
Perfect. Use your formula if you need to. There's 5 sides, you said, minus 2 times 180. So I know that they have to sum 540 degrees. So again, you just have to be careful with what you're setting it equal to because it depends on what type of polygon it is. If it has 3 sides, 180. 4 sides, 360. 5 sides, 540. 6 sides, 720. Just gotta figure it out. Okay. Careful with all these X's. Four and 4 is 8, plus 7 is 15, plus 5 more is 26 X's. You're just adding them all up. They're on the same side. Constants. Look, you could do this. I have plus 5 minus 5. That's 0. So I have 10 and 10 is 20. Okay. Let's plug the 20 in here kind of all together. So I want you guys to do this math in your head. Good practice. X is 20. 4 times 20 is plus 10 is 90 degrees. Okay, if you didn't participate this time, you need to this time. Going over to B. 6 times 20 plus 10. 5 times 20 minus 5.
95.
You guys are so smart. Four times 20 plus 5.
85.
7 times 20.
140.
Okay, how can I check if I did my algebra right?
Add them all up and it should equal 540.
Perfect. It should equal 540, right?
Exactly.
Okay, one last thing we need to talk about. That's all you need to know, basically. That's like the rule for interior angles. Now we're going to talk about exterior angles. So remember what exterior angles look like. We looked at a lot of them on triangles. Are angle measures that if you kind of extend the sides of your triangles, they lie outside of your triangle. Exterior. That's what that vocab word exterior means. The sum of exterior angles. So here's kind of your rule, I guess, for this. It's not even a formula. The sum of, oh no, I'll highlight it. The sum of exterior angle measures of any polygon, doesn't matter how many sides, is always going to be 360 degrees. Always. I'll show you a little visual in a second that helps you see why. So no matter how many sides here, if I add up, see how they're labeling all the exterior angles here, these are always going to total 360 degrees. They're giving you some different types of polygons to kind of prove this to you. Let's take a look at this. 120 plus 100. If I sum up all those exterior, do I get 360? Yes, I do. Okay, same for this one, same for this one. If you want to write it out, you can. This isn't a problem or anything. They're just showing you that this theorem is true. Adding all up. Yes, they equal 360. Okay. This is arguably even easier than finding the interior ones. It doesn't matter how many sides there are. It doesn't matter how many angles there are. The exterior ones are always going to total 360. All right, here's a little visual. Just a short 12-second clip here. So as you can see, they're showing you different types of polygons. You have a triangle here, quadrilateral here, and then they're also highlighting the exterior angles. So watch what happens. What they're going to do, it's like an animation here. What they're going to do is they're just going to kind of shrink down the lengths of the sides, which doesn't change the angle measures at all. and you can kind of see what happens to the exterior angles. Pretty soon they're going to shrink it down so that there's no sides. And they'll always form a circle, which is how many degrees? 360, right? You guys want to watch it again? You didn't see it? Oh no. This is not what it is. Video. Go back. We don't want the magic square. Okay, watch Amron. Now, guys, and this I think people were getting confused last chapter. If I change the lengths of the sides, it doesn't change the angles. That's what some people I think don't get. It doesn't change the angles, right? The angles are still going to be the same. I could have a equilateral triangle with all. I don't want to draw on this probably. With all the sides being 1 centimeter long, right? Or I could have an equilateral triangle where they're all 3 inches long. The angle measures are still all 60 degrees. Okay, so anyways, that's kind of where that comes from. Let's try a couple example problems with this. Again, not hard, but you just have to be careful when you're reading these directions. This one says, find the measure of each, now we're looking at exterior angles of a regular, which means what? Yeah, and then I can put this on a test and you guys won't know what it means. All sides and angles are the same. Regular decagon. How many sides are in a decagon? 10. Yep, just like a decade is 10 years. If you're thinking 12, dodecagons 12. Okay, so I don't even need to do a formula. What are the 10 exterior angles going to total? 360, right? Always. No matter how many sides there are, they're all going to total 360. So how can I find the measure of each of them? Divided by how many sides we have, which is 10. So they're each going to be 36 degrees. So. That's it. Last one here. Algebra 1. Find the value of x in this diagram. Are they pointing these to exterior or interior angles?
Exterior.
Exterior, good. So when I total these together, and there's a lot of them, how many degrees am I going to total these to? 360 every time. I don't even need to count how many sides or how many angles I have. I don't even need to use the n-2 formula. These are exterior angles. They're always going to be 360 degrees. Oofda. Start with totaling all your x's. You got 31 x's. They're all on the same side, so you're straight up just adding them. All right, constants. Negative 12, is that right? Yep, negative 12. And all we need to do on this one is solve for x. And we're done. 12. Two big ideas. Sum of the interior angles. You gotta take your number of sides minus 2 times 180. Sum of the exterior angles, always 360. Those are our two theorems for the first lesson.